You open a jar of honey. Golden, thick, sweet. It looks simple, just something bees make from flowers. But behind that jar is one of the most astonishing natural engineering processes on Earth, involving billions of bees working together like a perfectly coordinated factory. And it's not magic, it's precise biology, chemistry, and teamwork. Let's walk through how it actually happens, step by step. First, collection. Worker bees, the females who do almost all the work, fly out from the hive. A single bee can visit up to 100 to 150 flowers per trip. She uses her long proboscis like a straw to suck up nectar, a sugary water solution, about 80% water, 20% sugars, from deep inside the flower. At the same time, she collects pollen on her body hairs, but pollen is for protein, not honey. A foraging bee's honey stomach, a special second stomach, can hold about 40 to 60 milligrams of nectar per trip. She flies back to the hive, sometimes 5 kilometers away, burning some nectar for energy during flight.
Now comes the part most people never hear about. Step 2. The handover and initial processing. The forager returns and finds a house bee, younger worker, inside the hive. She regurgitates the nectar mouth to mouth, a process called trophallaxis. The house bee takes the nectar into her own honey stomach. Here, enzymes are added, mainly invertase, from the bee's salivary glands, and a small amount of glucose oxidase. Invertase breaks complex sucrose into simpler glucose and fructose. Glucose oxidase produces hydrogen peroxide, a natural preservative that kills bacteria. This mouth-to-mouth passing can happen several times, each time adding more enzymes and mixing. Step 3. Dehydration and ripening. The nectar at this stage is still 70 to 80% water, too watery to store long-term. It would ferment. So bees spread tiny droplets across the honeycomb cells. House bees fan their wings furiously, up to 200 beats per second, creating airflow through the hive. This evaporates water. At the same time, bees swallow and regurgitate the droplets repeatedly, adding more enzymes. The humidity inside a healthy hive is carefully controlled, around 40 to 50%. Bees even bring in water or fan harder if it's too dry or too humid. This process continues until water content drops to approximately 17 to 18%. At that point, the mixture is true honey, supersaturated sugar solution, about 80% sugars, mostly glucose and fructose, that's too concentrated for bacteria or yeast to grow. Step 4. Capping and storage. Once the honey reaches the right moisture level, bees seal the cell with a thin layer of pure beeswax, a cap. This airtight seal prevents moisture from re-entering and keeps the honey stable for years, sometimes centuries. A single worker bee produces only about 1/12 teaspoon, approximately 0.08 grams, of honey in her entire 6-week adult life. To fill one standard 500-gram jar requires the lifetime work of roughly 60,000 to 100,000 bees visiting millions of flowers. A strong hive with 50,000 to 80,000 bees can produce 20 to 60 kilograms of surplus honey per year after feeding themselves. And here's the astonishing part. Honey is one of the few foods that never spoils. Archaeologists found edible honey in ancient Egyptian tombs over 3,000 years old. Why? Low water content plus high sugar concentration plus natural acidity, pH 3.2 to 4.5, plus hydrogen peroxide from enzymes equals hostile environment for microbes. So when you eat honey, you're eating the concentrated life work of billions of bees across millions of flowers, processed through precise enzymatic reactions and airflow engineering inside a living hive. It's not just food, it's one of nature's most perfect preservation systems and a masterpiece of distributed biological engineering. What do you think? Did you know how many bees and flowers go into one spoonful? Or how the hive itself acts like a living factory? Drop your thoughts in the comments. I read every single one. In the next video, we'll look at something completely different. How uranium enrichment really works at facilities like Natanz,
and why one small mistake can destroy the entire delicate process.